Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 35 in our incredible new tutorial series where you are learning artificial intelligence on the Jetson Nano. I am going to need you to pour yourself a nice big mug of iced coffee. Also, because today is a particularly fun and important lesson, you may also pour yourself a nice cup of hot coffee. And now get ready to learn some cool new stuff. Hey, oops, I just touched my face. You're not supposed to touch your face. I touched my face. You're not supposed to touch your face. Okay, trying to be careful here in the midst of the coronavirus outbreak. Hopefully you guys are staying safe. And I need to say that you're going to hear me with a little bit of a wheezy voice today. Might hear me cough a few times. Never fear, I do not have coronavirus, but I am highly allergic to Clorox and to bleach. It's the one thing that I am allergic to, gives me a little bit of asthma. And guess what happens in the midst of a apocalyptic coronavirus pandemic zombie apocalypse? The cleaning ladies go around and spray Clorox all day long on everything. They just making me a little bit wheezy. So apologize if I cough a little bit, but I want to keep making these lessons because I know a lot of you are stuck at home and you probably want some cool stuff to do. So we are going to move forward with these lessons. Okay, I will need you to get out your Jetson Nano gear, and let me get a couple of things out of the way here. I need you to go and get your Jetson Nano gear out. I've got to clean this up a little bit. Okay, there we go. Get ready to learn some cool new stuff. Hey, as always, I want to give you guys a shout out who are helping me out over at Patreon. Your help is a huge encouragement to me. For you guys that are not helping out yet, look down in the description below. There's a link over to my Patreon account. Think about hopping on over there and hooking a brother up. I want to let you know I'm getting a lot of kind of offers from some of these online educational services wanting me to kind of work for them and make these videos behind a paywall. I don't want to do that. I want these videos to be free for everyone, okay? But you guys that can, if you would help me out, I would really appreciate it. Enough of this shameless self-promotion, and let's talk about what we are going to learn today. What your assignment was in lesson number 34, we had set up OpenCV on the Jetson Nano where it would track your face. So it would put a box around your face, a box around your eyes, and that was working. But what the assignment was for you to go away and for you to put together a system that would track the person's face by using a pan tilt camera so that the person's face was always in the middle of the field of view. Okay, and now what this is going to do is, if you haven't done some of the earlier lessons, you're probably going to need to go back and do those. And let me kind of show you the setup that we are using, the hardware setup. The hardware setup that we have, I probably at this point need to move out of your way. The hardware setup that we have is we have a camera, either the Raspberry Pi camera or a suitable webcam, and we have that hooked up to a pan tilt servo. Okay, now I showed you how to hook this up in lesson number 30. I had the links to the hardware, and then I also went through a build where I showed you how to put this together. And then I believe it was probably in lesson 31 I showed you how to use this servo driver board on the Jetson Nano. So if you have not been following along on all of these lessons at home, you need to go ahead and look at lesson number 30 and 31. And I'm going to try to get my focus back with a little luck. Okay, that looks pretty good. Want to keep this stuff in focus as we are doing this. So, in summary, if you have not followed along in all of these lessons, you need to go to lesson number 30 to build your pan tilt camera, and then lesson number 31 on controlling the servos. And if you can do those two things, you should be in a pretty good shape. You should be in a pretty good shape to follow along on this lesson. Let me check out here. Okay, so let's go ahead and jump into this. And so what I am going to need you to do, it with all these different screens and all this different stuff, it takes me just a second to get everything set up. So what I'm going to need you to do is I'm going to need you to open up your Visual Code Studio, and then we are going to create a new program. And so I'm keeping things in PyPro. Ooh, I need to move to a view that you can see there. Okay, so we're now in Visual Studio, and what I need you to do is create a new lesson. So it's going to be in the folder OpenCV, and then I'm going to create a new program. And what was the last one that we had done? It looks like it was OpenCV 22. So this is going to be OpenCV 23, and then I'm going to put face pan tilt dot tilt dot py. Okay, we have a fresh new program there. And I'm going to go ahead and make the view bigger of the code. And now we are going to go to our browser. And I need you to go to the most excellent www.toptechboy.com and then search on the lesson starting the Raspberry Pi camera. So this will sort of fire up and make the camera work. So I will come down here and copy this code so we don't have to start everything completely from scratch. Copy. And then we will go back to Visual Studio and we will paste this in. And now what we've got to do is we have to start coding. Now, again, this should be familiar to you from lesson number 30 and lesson number 31. And so if you really are confused by what I'm showing you here, you need to go back to lesson number 30 and lesson number 31. Now, in today's lesson, I am going to be using the webcam. And so I'm going to come down here and I'm going to uncomment out the webcam. And on mine, this should be set to 1, okay? And then we always like to move that window after we show it. So after we show the window, I'm going to go ahead and do a little bookkeeping, cv2.move window. And what window do I want to move? I want to move Nano Cam. And where do I want to move it? I want to move it to 0, 0, 0. I never remember whether that should be in parentheses or not. So let's go ahead and run this and make sure we get a happy little window. Ooh, move window. Ooh, move window. Yes, spelling is still important. Didn't move it. What did I do wrong? Let's quit out of that. Let's see. Win name and then X comma Y. That sure looks right to me. Win name is NanoCam. And then I go to 0, 0 and it didn't move it. So let's try it again. It's kind of bad to be having these types of problems so early on. Do you guys see what I'm doing wrong? Move window, NanoCam. Let me just put this in there again. This is kind of perplexing. I want to do move, okay, and I'll select that, and then the parameter is the win name, NanoCam, and then I want to go comma 0, comma 0. Right mouse click, run Python file in terminal. Okay. Have no idea why it didn't work the first time. Maybe you guys saw it, but that looks good. That's a pretty good picture too. I like that. Okay, let's go ahead and let's start getting ready to code now. So our goal is just to have that pan tilt camera track a face. So if we're going to do that, the first thing that we're going to need to do is, after importing and printing the version that we are working on, and a few of these things here, what I'm going to do is go ahead and we want to get those servos ready to go. So we're going to have to from add fruit underscore servo, and it's guessing it, so I'm going to take the guess. Import servo kit. So that's importing the library that will control the servos. Again, if you don't have that library installed, you can learn how to do that back in lesson number 31. Okay, so we've got the servo library. We've got to kind of set that up now, and so I'm going to say my kit, I'm going to create the object, my kit is going to be equal to servo kit, and then I need to tell it that this particular kit has 16 channels. So channels is equal to 16. That looks good. All right, now I got to kind of get those things up ready to go, so I'm going to initialize some variables, and I'm just going to say always start with a pan equal to 90 and a tilt equal to 90. Why? Because if you can go from 0 to 180, 90 is kind of in the middle, so I'm going to set the servo to begin with sort of in the middle. And so let's go ahead and put the servo in position. So I'll say kit.servo. Which servo? Will servo 0, and servo 0 is the pan one, and so then I'm going to say angle is equal to pan, and so that will put the pan servo at the 90-degree position, and then I'm going to say kit.servo 1, that's the other servo angle. What angle do I want? I want to put that in tilt. Okay, now I'm going to go ahead and run this because I want to make sure things are happy, and if we run it as we go, it's a lot easier to debug. So let's go ahead and run this and see if it moves that servo. Okay. Taking a second here. Takes a second, I think, with the servos to initialize them, and so that library takes a second. Okay, you hopefully heard that little sound, and you can see that it moved the camera to a different position. So we're talking to the servos. Boom, good milestone there. Okay, let's go ahead and quit out of that, and then let's go down, and in our while loop, let's see, we are reading in a frame, okay, and then okay, in the while loop, we're reading in a frame. Let's see here. Sorry about that. We are reading in a frame. And then as soon as we read in a frame, if we are going to be tracking things, what is it that we want to do? We want to do our image recognition, and we want to do that sort of stuff in grayscale. So we're going to create an image called gray, and it is going to be cv2.cvt color. And then which image do we want to convert? Well, frame, that's what we just read in. And then cv2.color. Oops, and I froze up over here. Sorry about that. Again, I have a USB bandwidth problem. Let me come back over here. USB bandwidth problem. And I'm back live now. Okay. Sorry about that, guys. Color, and then underscore BGR2 what? I'm just going to come down here and select to gray. And I need to move out of you guys' way here. There we go. Okay, hopefully you didn't miss any of that. Color BGR2 gray. All right, so that looks good. So now we have a grayscale image. And now what we want to do is we want to go ahead and create our face cascade. Okay, so we're going to say faces is equal to face underscored cascade, okay, dot detect multi. Okay, I'm not sure why that's not. That looks good. I'm not sure why it's not guessing. I like it when it pops up because that usually means I'm typing it right. Face underscore cascade dot detect multi scale, and then I want to detect on what image, gray, that I just created. And then remember, we got to put in a couple of parameters that it helps it find a face 1.3 comma 5. All right, like that. Okay, guys, I think to to make this a little quicker, because this is going to be a long video anyway, I'm just going to detect the face. I'm not going to detect the two eyes, and I'm going to detect the face, and I'm going to track on that. I'm just going to run this to make sure we don't have a problem yet. It's not going to really do anything, but I just want to make sure that we are running without crashing. Looks happy so far. Face cascade is not defined. I know what I did not do. I know what I did not do. Up here, before we do this, we've got to define the cascade. So face underscored cascade. I forgot to do this. Face cascade is equal to CV2 dot cascade classifier. Okay, it's recognizing that. That makes me happy. Now we need to give the path all the way to the cascade. So we're going to come back over here to our file explorer. I find it easier to just copy the entire path name. And so we are going to come over here and navigate. We're going to go to, once we've opened up our file explorer, we're going to go to desktop and then go to PyPro and Cascade. And then on this face, I'm going to go ahead and I am going to look at properties. Okay. And then there is the path. So I'm going to copy the path. And then that will give me the path. So I'm going to paste it. And then I just need to put the file. And my file was face.xml. And remember, we did this in the last lesson, setting these things up. And I think I'll go ahead and do the eyes. Okay, this is going to be a long lesson, but we will detect the eyes as well because it's good practice. So I'm going to copy that line because the next one will be almost the same. And I'm going to paste it. And this one, instead of face, is going to be what? Eye. Remember last time we downloaded those two hard cascades? And so this one will be eye. Now we should be able to detect faces and we should be able to detect eyes. Now when I come in and say faces and then say face cascade, it knows what face cascade is, all right? Because I'd forgotten to define that last time. So let's go ahead and run it and make sure that it's happy. On long programs like this, if you do all the coding and then run it, it's sometimes very hard to find your errors. And so that looks good. No errors. Everybody's happy. And so we're going to queue out of that. So now we have recognized faces. Okay. Now what we want to do is we want to step through the faces that have been recognized. So I'm going to say for x comma y comma w comma h, all right, for x comma y comma w comma h in faces. Okay, so faces is going to return to you a list of arrays, and each array is going to have the x and y of the corner of your face and the x plus width and y plus h of the other corner. So it's got the four numbers that you need for the two corners of the bounding box of the face that was detected. Okay, now what I'm going to do at the bottom here, since we're trying to track something, I'm only going to, if there was more than one face, I don't want it to be moving back and forth between the faces trying to track both of them. So I'm going to go ahead and put a break in here so it will only do the first one. So after it does the first one, then it will break, and if for some reason there was two faces, it would not try to find both of them. Okay, now I've got a box around the face. What I need is I need to know the center of that box. Okay, and so how would we define the center of the box? Well, I'm going to say like the X center, and what the X center is going to be equal to, it's going to be equal to the X plus half the width. So it's going to be the X plus the width divided by 2. Does that make sense? If this is the X position of the corner, then I would move over by the width divided by 2, and that would be the middle in X. And then similarly, Y center is going to be Y plus what? H divided by 2. I think that makes sense. Does that make sense? All right. Now, those are the center positions. What I have to do is I have to now find the error, right? If I want to be in a certain position and I'm in a different position, I've got to find the error. And so I'm going to have an error in the pan, and I'm going to have an error in the tilt. Okay, those are two things that I have to figure out. The error in the pan and the error in the tilt. Okay, well, what I need to know is I need to take that center, that X center, and I need to minus width divided by 2. Okay, and same thing, the error in the tilt is going to be equal to the object Y. Okay, and then minus the height divided by 2. So you can see that that X position, this X center and Y center is going to change every time, and then every time I'm going to create an error. All right, so as I move around, that error is going to move around, because as I move around, the center of my face changes. Okay, the center of my face changes. So I hope that that makes sense. And what this actually is, this is the width of the display, and this is the height of the display. And so I know that I am not explaining this really well, but if you think the whole display, the whole camera has a certain width, the whole camera has a certain height, all right? It has a certain width and it has a certain height. And the center of the image is the width divided by 2 and the height divided by 2. That's the center of the camera. And then this X center and Y center, that's the center of my face. And the difference between those two, that's the error. And that's what I'm having to drive out. Now with that, we got to make sure that we defined X center and Y center, which we haven't done yet. So I need to go back and I need to do that. And for my camera, I need to check and see what it is. Okay, for this camera, the width, the display width is 640 and the display height is 480. All right, so I need to use those down here, a different variable, display width and display height. Now let me make sure that I did that right. No, I didn't. Display width display height. Okay, guys, I apologize, I haven't explained this perfectly, but what I want is I want the center of my face to be in the center of the camera view. The camera is 640 wide and 480 high, and so if I take half of that and half of that, I get the center of the screen. Now, my face is moving, but I've got the X plus half the width and the Y plus half the height. So this is the center of my face. X plus half the width, Y plus half the height. That puts it here. Now the error is the center of the screen to the center of my face. And that is the error that I want to drive to 0 by moving the servos around. If that doesn't make sense, I think I explained it clearly there the last time, and if that doesn't make sense, you know, stop it and listen to it again. The one thing you got to be careful of is you've got to make sure that your display width for whatever camera you have is set correctly. So if you're firing up the Raspberry Pi and you're firing it up at a different screen resolution, the Pi camera, or you're using a webcam with a different screen resolution, you got to make sure that you set it for the camera you're using. Okay, I think that I am back on track here, and now we can continue to move forward. Okay. So now I have the errors. I have the error in X and I have the error in Y. Okay. Now, what I got to do is I've got to start driving those errors out. So what I'm going to say is if the absolute value of the error in pan, let's say, what if that is greater than 15 pixels? Okay, if the error is greater than 15 pixels, what do I want to do? Well, I need to say that the error is big, so I've got to subtract something. So I've got to say pan is equal to pan minus the error pan, and I'm going to divide by 50. Okay, if I just subtracted it out, it would swing that thing too hard and you would overshoot it. So I want it to kind of go in small increments. And so I'm going to try saying the pan is equal to pan minus error pan over 50. So I'm driving out 1/50th of the error. Okay, now why am I subtracting? Because the absolute value is greater than 15, so I want to make it smaller, so I'm going to subtract. All right, now what I can do next is I can say, I need to back out of that. I can say if the absolute value of the error, if the absolute value of the error in tilt is greater than 15, then what I want to do is I want to say tilt, I want to say tilt is equal to tilt minus error tilt divided by 50. Okay, so because I'm doing the absolute value, I only have to do two if statements, because if the error is negative, then it will change the sign in the error pan. So you see, error pan could be positive, it could be negative, but it's always going to be right. So it's kind of like I'm doing two commands with one if statement because I'm using the absolute value. If that doesn't make sense, stop and think about it a little bit. That if the error is positive, then it's going to be subtracting a positive number. If the error is negative, it's going to be subtracting a negative number, which is going to be adding. So you see, this will work for whether you're too far this way or too far that way. And same thing with the second if statement. Okay, now the thing is, I've just got to make sure that the servo can go from 0 to 180. And if I go outside that range, I need to stop so that I don't get an error message. So I've got to put some error checking in here. So I'm going to say if pan is if pan is greater than 180, then what I'm just going to say is make pan equal to 180, and that way it could never be more than 180. You're kind of pinning it there, okay? And then what I could do is I could say print, and I could say print what? I would print pan out of range, just so the person knows there's a problem. Okay, so I think that would work. I think the easiest thing, we're going to have to do this several times, and so what I'm going to do is I'm just going to copy, and then I'm going to paste, and that did not paste very well. Let's see, I need to take that back. Okay, so if pan is now less than 0, I would make pan equal to 0, and same thing, pan out of range. Now these two are going to be the same, only it's going to be tilt, so I'm going to copy those, and I've got to kind of fix that for tilt. So then I'm going to say Control V, and I think that did better that time. No, it did. Okay, so now I will say if tilt is greater than 180, then make tilt 180, and if tilt is less than 0, then make tilt equals 0. So now I've got things pinned on pan and tilt. I've got them pinned between 0 and 180. Okay, so that I think will be good. So we got all that taken care of. So let's see what we want to do now. We probably want to go ahead now and move the servos. So just like we did before, I'm going to say kit.servo, and I'll start with the pan. I'll start with the pan servo. So I'll say kit.servo, and that was servo 0 is the pan one, and it's going to be equal to pan, and we calculated pan up there just a couple of lines ago. All right, and then what we're going to do is we are going to say kit.servo, and now we're going to do the tilt servo, which is servo 1, and then we are going to say that is equal to tilt, and we just calculated tilt again a few lines ago. All right, so that should move the servo. Now just for fun, I'm sorry this is going to be a long lesson, but I do want to go ahead and I want to put the eyes on there, and so that'll just take us a second. So what I'm going to do is I'm going to create a region of interest from our gray, so we're going to be making a gray region of interest because we're looking for eyes, and if we're looking for something we need to be using a grayscale, and that is going to be based on our gray image which we created above. And we're going to go, the region of interest is from Y to Y plus H, okay? And then we're going to go from X to X plus width. Now what you got to remember is that when we're doing this with these brackets, we're treating gray as an array. And when you have arrays, you go rows first and then columns. And if I go rows first, that is the Y value. So it's rows, commas. That's Y, X. So you got to be careful. If you're doing this as points, you go X, comma, Y. But if you're treating it as rows and columns, it's more like you go Y, comma, X. And we've run into that before, and I just hope you guys will remember that. Okay? And then we're going to go ahead and make an ROI color, because that's what we'll draw on. And the ROI color is going to be equal to the that was the frame, I believe, frame, and then it's going to be the same thing, that same range. All right, that looks good. So now we're going to go ahead and we're going to find our eyes, and so we're going to say eyes is equal to I Cascade, and then we're going to do a detect multi-scale, And then what do we want to detect in? ROI underscore gray. And then do you remember that for these eye detection, we don't need to put any parameters. It kind of finds the eyes without putting any parameters in. And now we're going to need to go for, and we're going to need to go from the I, X, I, Y, I, W, I, H. Okay, X, Y, W, H, just like before, but I put the E in front of it so it'll be different than the X, Y, W, H that we use for faces. And so now we're going to step through the eyes here. All right, and we'll want to do both eyes, and so in eyes. So it finds the eyes. Now we're going to step through the eyes, and it's only looking for the eyes inside the face. Okay, now we'll say CV2.rectangle. CV2.rectangle. And then where do I want to put the rectangle? I want to put it on ROI color because I want to show this to show up on the color image. And then we're going to go, where do we go? EX comma EY, that's the upper left of the found eye. And then I need to go to the bottom right of the found eye, which would be EX plus E width, comma, and then I'm going to go EY plus EH. EY plus EH. And I think I'm missing a parentheses, right? Did I miss that? EXEY. Okay, and then EX plus EW. All right, so that is going to be then the corners of the eye. And then you'll go through the for loop another time, and it will do the other eye. Okay, we got to put a color on there. So let's go ahead and let's make the eyes blue. 255, comma 0, comma 0. And then let's put a width of 2 on it. So that is going to box the eyes. This should make sense from that lesson that we did last time. This is very similar to the lesson we did last time. Okay, then I think what we will do is we will then show the faces. Man, this is kind of scary, isn't it? All right, I need to kind of see if I can give you guys a view. I want to try to give you guys a view of the camera. So let's see if I can move this. I want you guys to see the camera moving, so let's see if I can kind of show you a little bit more of the action. And then I'm going to kind of put this more over here, pointing that way. And let's see if I can bring this up a little bit. Okay. Hopefully that will work. We'll have to play around with this a little bit, but I guess the work at hand is to just see if this program's going to run. The suspense builds. I should have made you guys hold your breath. Ooh, invalid syntax. Oh, ROI gray. Did you guys see my error there on ROI gray? Look at that. That should have been a what? That should have been a plus. Did you guys catch that? Let me show you where you can see what I'm doing. Right. That should have been a plus there. And then from X to X plus W. All right. That was kind of a big deal. So let me go ahead and run this. Still invalid syntax. CV2 rectangle. I think I had on the rectangle statement, I had an extra closed parentheses. It's one of those where it puts it in for you and then I put it in and therefore we both put it in, so we have too many. All right, let's run this. So far, so good. Okay, boom. Look at that. Good news is the program didn't crash. The bad news is we've got no idea whether this thing is going to work or not. So let me see if I can. Okay, that's kind of interesting. So let's see if it will find my face. Oh. That was kind of awkward. When it saw my face, it crashed. Okay, width is not defined, so there was something that I should have done there where it said width in line. I probably used the wrong variable name. Which line is that? Line 28. Did you guys catch that when I made that mistake? Line 28. Okay, so I say error pan. I think that should be W. No, this is the X center. I got to think what error pan is. This would be W divided by 2, I do believe. And this was Y center, I think. All right, let's think about this on the error pan. It's the difference between the center and okay, X center and Y center is the center of my face. Okay. And the center of the screen would be display width and display height, I believe. Now I am completely confused. All right. X center is the center of my face. The center of my face would be X plus W over 2. That's the center of my face. Y center is the Y center of my face, and that's Y plus H divided by 2. The error is X center minus the display width over 2. So I need to make this one display width. Display height. Okay. Where is the center of the display? Well, it's the width divided by 2. And it's the height divided by 2. And the error is from where the X center is to, which is the center of my face to the center of the display. Does that make sense? So let me get full screen here and go through this. And I'm sorry that I'm not explaining this better. I have the display width. The display width divided by 2 is the center of the display. The display height divided by 2 is the center of the display. Now, as my face moves, this is still the center of the display. This is the position of my face. The center of my face is the X plus the width of my face divided by 2 and the Y plus the height divided by 2. So now, X center, Y center is the center of my face, and display width divided by 2 and display height divided by 2 is the center of the screen. And if I subtract this from this, then that is the error. Okay. I hope that made sense. Stop and listen to what I said again if it doesn't make sense. But let's try that and see if that will run. So far, so good. Okay, it's running. Now let's hope that my face doesn't crash it this time. My face crashed it again. Okay, error in line 46. I must have not. Oh, okay. I see what I did. Did you guys catch that? This should be dot angle. All right. I didn't give it that parameter, dot angle. Did you guys catch that? I will need you to hold your breath this time. I think part of our problems is we're not holding our breath, so let's try that. Please run this time. It's hard to hold your breath this long when it takes so long to load the library. All right. Won't give a boom yet, but at least it is running. So let me come over here with the face. Okay, now it is not... it's still crashing when... look at that. Did you guys catch it? It was in line 33. Line 33. I had a typo. Error. Tilt. Okay. So tilt is equal to tilt minus error tilt over 50. I hope you guys caught that. Okay, let's run it this time for real. I think it's going to run this time. It kind of hurts my feelings when every time it sees my face, the program crashes. I'm just saying. Okay. Let's see here. Okay, so we're coming over here to give it a face. Look at that. It is tracking me. Boom. Boom, look at that. Now we didn't put, one thing we didn't do is we didn't put the rectangle in around the face, and that would probably be useful. So let's do that. Let's go ahead and put a rectangle in here on the face. And so we need to come back over here. And for X and faces, okay, we do all of that. And where would be a good place to do that? Let's see. I think we would do it right after we entered. Right after we enter this for loop. Let's go ahead here and say cv2 dot rectangle, and then the rectangle is going to be on frame, and it is going to be at x comma y, right, which we get right above there, and then it goes to the other corner, which is going to be x plus width, x plus w, comma y plus h. I really think this is going to work. And then we're going to make it, let's go ahead and make it red, so it would be 0, 0, 255. And then we are going to go at about a 2, okay? A 2 line width. So let's try running this again. This is going to work this time. Okay, there it goes. All right, so now let's give it a face to look at. All right, look at that. We got our rectangle. Boom, boom. Okay, double chest bump. Okay, I think that as engineers, we really need to celebrate our successes more. Why should the professional athletes do a double chest bump and not us engineers? I think we should start adopting this. And in fact, you could start doing this at work and for other reasons too, to celebrate successes. But look at that. Swinging around this way. tracking in real time. Jetson Nano artificial intelligence tracking my face. I need to create a website, www.trackmyface.com. Look at that. Do you see wherever I go it puts my face in the center? Now I'm going to move off of scale or out of range and see if the program crashes. So if I move further than it can look, okay, I moved out of the field of view and it did not crash because we thought ahead and we put those if statements in. Okay. I kind of got a little bit too far ahead of it. Okay. Let's make sure if I stand up it will track. I went a little bit too fast. Okay. It's tracking up, tracking down. The one thing I don't like about it with this camera, it looks like the camera's trying to do an auto white balance. And so what happens is when it sees the green screen behind me, it tries to do an auto white balance. So I wish that I need to probably go in and figure out the command where I can turn that off. Okay, turn that off. All right, guys. I am just super excited about this. I don't know if it can find me again. Okay. Got a little bit out of range. Okay, there it is. All right, guys, I am just super excited about this project. This is really we have done a lot in the last 35 lessons, and I hope you guys feel like that you've learned a lot. I mean, you are really doing some artificial intelligence now, and I think this is a pretty cool project. Okay, what we've done so far is we've used pre-trained models. Now, the same type of thing, you can go back and you can look at those cascades that I showed you on the OpenCV GitHub. You can download other of those cascades and you can track on other things, and you can kind of play around with that. But you're to the point now of doing some pretty sophisticated stuff. So I've got to pause now and figure out where we're going next with these lessons, but I really am having a lot of fun with this and hope that we can continue to do more lessons. Okay, guys, again, I really appreciate you guys that are helping me out on Patreon. It really means a whole lot to me and allows me to continue making these videos. If you guys aren't doing that yet, think about helping me out. And then also, you guys, if you would give me a thumbs up, that helps a lot. Think about subscribing to this channel. Think about sharing this with other people. Sharing it with other people. Get more people involved in this work. All right. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.